start making a quick note of this problem. So shall we get started? Right. So the last set of problems that we are supposed to see is based on a moving coil galvanometer, right? So we'll see some problems that are from moving galvanometer. Right. So in a moving galvanometer, let's forget about all these things. What are the only equation that is helping us to derive the other values? So NIVA is equal to K times alpha. So it will be equal to K alpha divided by NBA. Alpha will be equal to NBA divided by K into I. Right? So that's what these two equations are. Yeah, anything is fine. This is called as torsional constant. So this is called as the torsional constant. Okay, alpha is the amount of deflection that is produced in the coil, and N stands for the number of turns, I stands for the current, B stands for magnetic field, and A stands for the area of the coil. Right? Having said this, these two are the expressions given for current and the deflection produced. By rearranging these equations, if you write I divided by alpha, right? If you write I by alpha, then I by alpha is equal to what is that going to get? You will get K divided by NBA, where this is measured in terms of ampere per division. And this physical quantity is called as the figure of merit. Am I right? So figure of merit. Right? In a similar way, if I write alpha divided by I, this is going to be NBA divided by K, which is called as current sensitivity. So it is called as the current sensitivity. There is another quantity called as alpha divided by V, which is given by the expression NBA divided by K times R, which is going to be called as the voltage sensitivity. Right? So these are all the terms that we are supposed to know before getting started. Clear? Okay. Just a second. Is it clear? Shall I proceed? So let's see the first problem that is based on the moving coil galvanometer. So it says a rectangular coil of area, how much? 5 into 10 power minus 4 meters square. How many turns are there? The number of turns is going to be 60. It's put above one of its vertical sides. Okay. A coil is in a radial horizontal field of 90 Gauss. So, you know what is the meaning of radial magnetic field? Radial magnetic field means the angle between the magnetic field and the coil is always 90 degrees. So, the torque will always be maximum. Right. So, B is equal to 90 Gauss, or this can also be written as 90 into 10 power minus 4 Tesla. Because Gauss is the CGS unit of magnetic field. SI unit is going to be Tesla, right? So, the torsional constant of the hairspring is connected to the if a current of, so K is equal to how much? If the value of current that is flowing through the galvanometer is 0.2 milliampere and it produces an angular deflection of 80 degrees. So all that we need to find is K, right? Suppose, let's assume you don't remember the formula at all. All that you need to remember is NIBA is equal to K alpha, which implies K is equal to NIBA by the value of N 60 into IS 0.2 milliampere. So 0.2 into 10 power minus 3 into B is how much? 90 into 10 power minus 4. The whole divided by alpha is 18. Right. So 18 cancel 85 into 60 is going to be 300 into 0.2 is which one? Yeah. So NIB and area is 5 into 10 power minus 4. Right? I've written everything, no? Yeah. So this 18 is going to cancel this 95 times. So let's calculate. 5 into 0.2 is 1. So 1 into 5 is 5. Yeah. Coming again. So 5 into 0.2 is 1. 1 into 5 is 5. So 5 into 60 is going to be 300 into 10 power how much? 10 power minus 11. Right? 300 into 10 power minus 11. But what is going to be the unit for it? Observe. What is NIBA? It is a magnetic dipole moment. It is not the magnetic, it is the torque. Correction. NIBA is torque. So how is torque measured in? Newton meter. Divided by, what is the value of alpha that you substituted? 18. 18 is in terms of Newton meter per degree is going to be the unit. So 300 into 10 power minus 11 or 3 into 10 power minus 9 can also be written. Is the point clear? So let me know if it is done. You're done copying it? The second question in this topic says, a rectangular coil having turn of length 5 centimeter, length is 5 centimeters, so 5 into 10 power minus 2 meter, and breadth of how much value? 2 into 10 power minus 2 meter, is suspended freely in a radial magnetic field. It is suspended freely in a radial magnetic field of how much value? Equal to 2.5 into 10 power minus 2. What is Weber per meter square? It is Tesla. So it is in the SI unit. It's constant of the suspension fiber. The value of K is taken to be 1.5. So 1.5 means, can I write it as 3 by 2? So 3 by 2 to the power minus 8 meter per radian. So here the angle is measured in terms of, be careful, okay? The coil deflects through an angle of, the coil deflects through an angle of 0.2 radian. So whenever they give you torsional constant and all that you need to do calculate torques. See, if torsional constant is known, alpha is known. What are you supposed to do to calculate the torque? K alpha. But one thing that you need to ensure is always have a look at the units. Here, if you observe, the value of K is Newton meter per radian. Suppose this is given in terms of degree, you need to convert this to radian and then multiply. Don't make the mistake of directly multiplying it. Only because you need to get what is supposed to happen. This radian and this radian, the denominator should get cancelled. Right? Sometimes few people make mistake directly multiplying. Don't do that. Look at the units. Okay. So I think most of the data is taken out. So the coil deflects through an angle of 0.2 radian when a current of how much value? When a current of 2 microampere. So 2 into 10 power minus 6 ampere is passed through it. Find the number of turns in the coil. So NIBA is equal to alpha. N into what is the value of I? 2 into 10 power minus 6. What is the value of I? Sorry, I. So I get it as 5 by 2 into 10 power minus 2. What is the value of A? Multiply these two. So 5 into 2 is 10. 10 into power minus 4 is 10 power minus 3. I hope I'm clear. So 5 into 10 into 10 power minus 4 is 10 power minus 3. Okay, this is equal to how much is the value of K? It is 3 by 2 into 10 power minus 8 into what is the value of alpha? It is going to be 0.2. So 2 will cancel this 0.2, 0.1. So 3 into 0.1 is going to be 0.3. Or I can write this as 3 into 10 power minus 9. Did you understand? 3 into 10 power minus 8 into 10 power minus 1. It will become 10 power minus 9. I hope I'm clear. Right. Now what we can do is look at these two sides. So 2 and 2 here is going to get cancelled. 5 will go to the other side in the denominator. 3 by 5. 0. Right. So n will be equal to, can I directly write it? 0.6 into, this is 10 power minus 9, no? 10 power minus 9, the whole divided by 10 power minus 11. 10 power minus 6 into 10 power minus 2 into 10 power minus 3. So 6 plus 2 is 8 plus 3. So 10 power minus 11. This will go to the numerator. So it becomes 0.6 into 10 power 2, or it is also going to be 60. It is going to have right. See, 59.2 means for you to make that 0.2 of turn greater than 59, how many turns do you need? 60. See, suppose you want a whole number, is supposed to be 59.2 means generally nobody will have that kind of a wind. I've never seen that kind of in real time I'm talking about. Nobody will turn it half and leave it. Okay, so that is why it will be a multiple of something. But if at all in a hypothetical situation, if something like that comes, okay, you need to approximate it to a next number. There is no rounding off. You bring it to 59. Right. Shall I proceed? Yeah. So third problem based on the same concept. The coil of a moving coil galvanometer has an effective area of how much value? 5 into 10 power minus 2 meter square, and it is suspended in a magnetic field. See, whenever you use the radial or when galvanometer comes, you should understand that it is radial magnetic field. Okay. So B is equal to how much? 2 power minus 2. There is a mistake here per meter square. Okay. So 2 to 10 power minus 2 Tesla. If the torsional constant of the suspension fiber is, so K is equal to 4 into 10 power minus 9 Newton meter per degree. Okay. Find the current sensitivity. But here there is a twist. Find the current sensitivity in microampere. So you need to find it in terms of degree per microampere. Means the numerator should be in terms of degree, the denominator should be in terms of ampere, not in terms of ampere. Okay. So here when they say effective area, right, the number of turns is also getting multiplied into this. Having said that, if I write NIPA, then this N to A put together can be replaced with this value. How much is that? 5 to 10 power minus 2 into, I don't need to find the value of I separately because I by, they're asking alpha by I. Alpha by I. So I into, what is the value of B? 2 into 10 power minus 2 into, there is no A, N into A put together is 1. I hope I'm clear. Is there any doubt for anyone? 4, this one. 4 into 10 power minus 9. So this is the left hand side data. Is equal to 4 into 10 power minus 9. Don't write the value of alpha. Alpha by I is what you need to find. So we cancel this 4 2 times. And 2 will cancel this 5 2.5 times. So what will be the value of alpha by I? So alpha by I, to bring the 10 power minus 9 this side. So 2.5 into 10 power minus 4, the whole divided by 10 power minus 9. Am I clear till this point? But actually, if you look at the unit of this is going to be per ampere. So what you need to do is to make this microampere, you need to borrow 10 power minus 6 from this. So if you take out 10 power minus 6 from this, how much is left out? So 10 power minus 9, from 10 power minus 9, you are taking out 10 power minus 6. 10 power minus 3 is left out. So the 10 power minus 3 numerator. I hope you would understand. So when the 10 power minus 3 goes to the numerator, how much will the value be? It will be 2.5 into 10 power minus 1. So it will be 2.5 into 10 power minus 1 degree divided by 10 power minus 6 ampere. This whole thing put together is what is called as microampere. So what is going to be the current sensitivity? It will be 0.25 degree per. I hope I'm clear. Math எப்படின்னு கேக்குறியா? Okay. See, what is microampere? 10 power minus 6 times ampere, no? the value I have in the denominator is 10 power minus 9. So what I'm doing to this is I'm writing it as 10 power minus 3 into 10 power minus 6 ampere. Let me check the answer once. The video almost ready. Already சொல்லியிருக்கேன். Shall I proceed? So we'll do one last problem based on this concept. The last. The fourth problem based on moving coil galvanometer and its sensitivity is a current of 200 microamp deflects the coil of a moving coil galvanometer through an angle of 30 degrees. So I is equal to 200 into 10 power minus 6 ampere. What is the value of alpha? This 30 degrees. What should be the current to cause the rotation pi by 10 radian? Meaning what they're asking is, if this is the value of current, we are able to get alpha to be 30 degrees. What should be the value of I dash? So the same galvanometer experiences a deflection of alpha dash, which is pi by 10 radian. Having said that, you also need to find what is the sensitivity of the galvanometer. Here sensitivity means current sensitivity only. See, current sensitivity, you can directly find it from this step itself. So what you need, it is going to be 200 into 10 power minus 6 degree per ampere. Right, it will get cancelled. So how much will it be? It will be 10 power 7. Right, 10 power 7 divided by, oh sorry, my mistake, sorry, correction. So it will become 10 power minus 5, no? So 20 into 10 power minus 5. So it will be 1.5 into 10 power 5 per ampere. So 1.5 into 10 power 5 degree per ampere. Or if you want to write it in terms of microampere, you can still write it as 0.015. No, 0.15 will come. So I can write it as 0.15 degree per microampere also. That is the sensitivity of the galvanometer. I hope. Now, to answer the first part of the question, so since it is the same galvanometer in the case, what should be constant? Sensitivity itself should be a constant. So alpha divided by I should be equal to alpha dash divided by I dash. See, if at all you have a doubt of why I wrote it like this, observe what is the only equation I had been using to solve all the problems. Equal to K. So observe, number of turns is a constant. The amount of magnetic field is produced is constant because you're using a permanent magnet. Area of the coil is constant. Constant. Right. So what is the only change that's happening? When the value of I is changing, there is a corresponding change taking place alpha. From here, I can conclude I is directly proportional to alpha. I can say alpha divided by I is a constant. So alpha by I is nothing but current sensitivity. So that is the logic I used here. So you need not do this much. You need to understand that this is what is the background. Am I clear? So what is alpha by I? Here, what is the mistake I should not do? First alpha is given in terms of degree, second is given in terms of radian. So don't directly substitute. Right? They should be dimensionally consistent also. Having said that, convert 30 to radian. That is easier. No, it is going to be pi by 6. Or this can be written as 18 also. So pi is 180 by 10. So 18 degrees. That is also fine. Either of them you can do it. So pi by 6, the whole divided by what is the value of I? 210 power minus 6 is equal to what is the dash? Divided by I dash. We need to find I dash. So pi will get cancelled. This will be 3 times. This will be 5 times. So I dash will be equal to. So if you go to the other side, how much is it going to be? 600 into 10 power minus 6, the whole divided by 5. So cancel this 120 times. So it is going to be 120 microampere. And one more checkpoint here is, listen to this carefully. Since I is directly proportional to alpha, more is the value of I, more will be the deflection. Makes sense? So in the initial case, if you see the value of I that you sent is 200 microampere. 200 microampere produced a deflection of 30 degrees. So I dash, we got it as 120. So 120 is lesser than 200. So alpha should also actually decrease. Is it decreasing? It is 18 degrees. So it is so you need to do this check also. If you get a value greater than 200, you're wrong. That is what I'm trying to say. Clear with that? Clear? Okay. Go to the that is problem that is based on conversion of galvanometer into an ammeter and voltmeter, right? So first thing, just let's recollect the concept. If you have galvanometer, if you convert the galvanometer to an ammeter, what is it supposed to do? You need to connect a shunt resistance, right? You connect a resistor RSH in parallel to the galvanometer so that this whole circuit is going to be treated like an ammeter. So what will it do? If the value of current that this ammeter is supposed to measure is I, then how much should be the current through the galvanometer? The current through the galvanometer is always fixed. Its value is it's called full scale deflection current. So how much will be the remaining current flowing through R shunt? I minus Ig. So what is the relation between these two? Ig into Rg is equal to Ig into Rg is equal to I minus Ig into R shunt. So basically what I did is applied the Ohm's law. So since these two are in parallel, the potential difference for these two terminals should be the same as the potential difference across these two terminals. Right. So what should be the value of R shunt? R shunt will be equal to Ig into Rg, the whole divided by I minus Ig. So am I clear with this? So that's what they will ask. What is the shunt resistance that you need to connect so that it is converted to a ammeter of this much value? That value will be given here. That value of I will be given here. Am I clear with that? Now, the second part is some will ask you the resistance of the ammeter itself. So what is the resistance of this particular device? That is RA is how much? RG and R shunt, how are they connected? RG is the resistance of the galvanometer. RG and R shunt, how are they connected? Parallel. So in parallel, what you do is R1 2 divided by R1 plus R2. So that is what this value is. Okay, I'm just adding SH here so that you can remember it as shunt. Instead of if I write S, you will think it is series. So that is why I changed it to SH. This I've already taught. This is already in your notes, just a part of recollection. And the second type is conversion of a galvanometer to voltmeter. So when you need to convert a galvanometer to voltmeter, you will take a high resistance value and connect it in series. So if I say that the potential difference between AB, where this whole device put together is called as this whole device is what is called as the voltmeter. If this voltmeter is going to measure the potential between A and B to be of the value capital V, then V is equal to how much? And the galvanometer is always it is Ig. So V is equal to Ig into completed Rg plus Rs. So what should be the value of the series resistor that you will connect? From this, you know that V by Ig, so Ij will come this side, V by Ig will be equal to Rg plus Rs, which implies Rs will be equal to V divided by Ig minus. So if they give you what is the potential difference the voltmeter is supposed to measure, you can substitute that value here. Ig and Rg will be known to you. You can calculate it. So this is the value of the series resistor that you need to connect to convert a galvanometer into a voltmeter. Okay. So galvanometer to voltmeter. Right. The next question that they can ask is what is the resistance of the voltmeter itself? So this consists of many resistors. Look at it. What are they? Rg and Rs. How are they connected? So Rv will be equal to Rv means resistance of the voltmeter. Simple. They both are in series. So Rg plus, that's the answer. So this is the resistance of the voltmeter. So you need to be. Suppose they ask you what is the series resistor that you need to connect it to. What is the series resistor you need to connect a galvanometer to volt? You should use this formula. If they ask the resistance of the voltmeter itself, then you should use this formula. In a similar way, what is the shunt resistance that needs to be connected across the galvanometer to an ammeter? If they ask what is the resistance of the ammeter itself, use the bottom one. This is where you will have the maximum confusion because they appear to be similar. But remember, the resistance, important parameter is you should know how much is the value of current that ammeter is supposed to measure. Whereas if you want to find the resistance of the ammeter, all that you need is you need the resistance of the galvanometer and the resistance of the shunt. Is that clear? And mistake that happens is right like this. Connect a shunt resistor in series with a galvanometer to convert it to voltmeter. Because that word shunt is stuck in their mind. Shunt means diversion. So if you use the word shunt, it comes only in parallel. So don't make the mistake of writing a shunt resistor connected in series to a galvanometer. That is grammatically wrong. Don't do that mistake at all. I've seen it in many papers. That is why I'm telling you. I hope you're able to understand. No? So what does shunt mean? Shunt is a resistor that is used to divert the path. Where will diversion of current take place? Only in parallel. Whereas in series, the diversion is not going to take place. It will be in a continuous path. Okay, so don't make that mistake. Okay, so these are all the basics that you need to start solving the problem. Am I clear? Right? Does anyone want to make a note? Are you done? You're done noting it down? Shall I proceed with the problems? So let's try this. So this is the first problem that is based on converting a galvanometer to ammeter and voltmeter. All right. So read the question carefully. It's very, very important. Listen. A galvanometer with a coil resistance of 12 ohm. So what is the first data that is? They have given the value of Rg, which is 12 ohm, shows full scale deflection for 2.5 milliampere. So what is the value of Ig? 2.5 into 10 power minus 3. How will you convert it into ampere? 7.5 ampere. They ask you how you convert it. All that you need to do is find the shunt resistance value and say that this resistor should be connected in parallel to the galvanometer. So indirectly, all you need to find is R shunt, which is given by the expression Ig into Rg divided by I minus Ig. See, if at all you forget this also, I have told you the method to recollect it. What is happening? Galvanometer and the shunt resistor are in parallel. So what is the current through the galvanometer? Ig into Rg. What is the current through the shunt? I minus Ig. So rearranging it to get this equation. I minus Ig is always in the denominator. Observe, do you have all the data in your hand? You have Rg, you have Ig, all you need is a value of I that is given here. So I is 7.5, that is a maximum value. Actually, it is a range. So 7.5 minus 0 is going to be 7.5. See, suppose, just, see, they'll not give you like this. Suppose they give you a problem like this. An ammeter of range 1 ampere, 8 ampere. You substitute 8, you should substitute 7. Because that is the maximum value it can measure. It's a relative quantity. See, nobody will frame that kind of a question, right? Basically, for these measuring devices, it's 0 only. Unless they want to confuse you. If at all it comes, I'm saying. So here, 7.5 minus 0 is what you need to substitute. So Ig is going to be 5 by 2 into 10 power minus 3 into Rg is 12, the whole by I minus Ig, 7.5 minus. See here, what I'm going to do is 7.5 minus 2.5 into 10 power minus 3 is there. No. See, 2.5 into 10 power minus 3 is a very, very, very small value. This kind of approximation is done mostly in the case of ammeter. Listen to this carefully. Compared to 7.5, 2.5 into 10 power minus 3 is a very small value because it's getting shifted to 3 decimal values. So what you can do is 7.5 minus 2.5 into 10 power minus 3 can be approximated to 7.5 itself. That is an important point to be noted. Cancel this by 16 into 5 is 30. So it is 30 into 10 power minus 4 divided by what is the approximated value? 7.5. And remember, 7.5 into 4 is 30. So answer will be 4 into 10 power minus 4. Observe an important point here. The value of the shunt resistance is also very small. The reason why you make the shunt resistance to be small is because galvanometer is a sensitive device. Observe. I'll just explain this point. Listen to this. This I is there. No, this is getting divided. Galvanometer is a sensitive device. You're not going to pass more amount of current through it. You observe in both cases. No, I'll tell you. So the galvanometer is full scale deflection current. All other remaining high value of current, you want to pass it through the shunt. That is why you make this resistance less so that more current is able to pass through it. See, this kind of a question can also be framed in assertion reason. Why do you understand? So give you a statement, shunt value should be less or more. Should you calculate a high resistance value in parallel with the galvanometer or a low resistance value in parallel with the galvanometer? What is the answer? Low resistance. And why do you do that? You should know the reason. So that you allow maximum current to it. Then, what are we doing here? You're connecting a high resistance value in series because the galvanometer cannot act as a blocking agent. If more current is flowing, galvanometer will not have very high resistance to stop it. Whereas this will have very high resistance so that you're still controlling the amount of full scale deflection current through the galvanometer. Did you understand? and very two values there. Is that the point here? Yes. So that's why if you observe this value is small. It's a real time value. Am I clear with that point? No. Right. What is it you're going to write? How will you present it? See, this is a shunt resistance, but what is it you need to write? They didn't ask the question of how much should be the shunt resistance that needs to be connected. They asked how will you convert it into a ammeter. So how will you do it? You'll say you'll take the shunt resistance of 4 into 10 power minus 4 and connect it in parallel to ammeter. Sorry, connect it in parallel to the galvanometer. Is that point clear? Right. So that statement is expected, or else again they'll cut half mark for you unnecessary. When you know it, write it. It's useless also to extra information, it's fine. So what about the second part of the question? Voltmeter being converted, sorry, galvanometer being converted to voltmeter of this range. For that, what is it you need? You need a series resistor. So RS is equal to V divided by IG minus RG. See, initially these formulae will appear to be tough to remember, but with practice you will get it. If at all you forget also, you should be in a position to derive it. How will you derive this? V will be equal to IG into RG plus RS. So bring IG to the left hand side and RG to the left hand side, you will get this formula. Minus 3 other. Okay. So correction here is 10 power minus 3. But still it is a okay. So I wrote 4 here, so I wrote 4 there also. So this is a correction. Okay. It is 4 into 10 power minus 3 itself. But still it's a lesser value. Right? So what is the value of the series resistor here? R is how much? 10 divided by what is the value of IG? 2.5, but 2.5 into 10 power minus 3. The value of RG it is 12. Will cancel this 4 times. So 4 into 10 power 3 is 4,000. 4,000 minus 12 is 3,988. So 3988 ohm is the value of resistance to connect it across the galvanometer to convert it to a voltmeter. So this is the first part of the question. This is the first part. What have they asked in the second part? Determine the in each case. So asking you the resistance of the ammeter and the resistance of the voltmeter. Okay. Do that and show. So what is the resistance of the ammeter? It is going to be RG into R shunt divided by RG plus R shunt. What is the value of RG? It is 12 into what is the value of R shunt? It is 4 into 10 power minus 3, no? The whole divided by plus 4 into 10 power minus 3. What is the approximation you can do here? You can write it as 12 itself. So if you write this as 12, then this 12 and 12 will get cancelled. You're going to have 4 into 10 power minus 3 ampere. Means you're trying to say approximately will be the shunt connecting. So there is an approximated value. What about so resistance of the voltmeter is going to be RG plus RG plus kind of 8. So adding, you will get 4,000. RG is 12, no? RG is 12 and RS is 3988. That's what we calculated. Am I clear with this? Shall I proceed? So in this class, when ammeter is put in a circuit, so we connect this ammeter across any circuit in series. So when an ammeter is put in a circuit, read slightly less or more than the actual current in the original circuit. Is it going to read slightly less or slightly more? Suppose let's say there is a circuit across which there is a current of 2 ampere that is passing. You connect an ammeter to measure the 2 ampere. They're asking, is the ammeter going to show 2 ampere or less than or more than that? Why do you think it will be less? It is connected series. Actually, it will read lesser value only because what is the resistance of an ideal ammeter? But what is the resistance of the ammeter here? It is approximately this value only, no? So since it has some resistance, what will happen is this will also draw some current. So when this is also going to draw some current, what happens? The value of the current is less. Similarly, when a voltmeter is put across a slightly less or more than the original voltage. This is also going to measure a value less. The same is going to draw some current. So initially what will happen is there will be some potential drop across the ammeter. In a similar way, across the some current drawn by the device. Is the point clear? So in both the values will be lesser than the original value. Is that point clear? Yeah. This. The circuit slightly less than the actual current in the original circuit because of very small resistance introduced circuit. Resistance is how much? That 4 into 10 power minus 3. Since you introduced it, it will draw some current. In a similar way, what is going to happen here? So voltmeter is also going to draw some current. It will also draw some current. Hence, it will read a value slightly lesser than the original value. Shall I proceed? One minute. Try this. An ammeter of resistance 0.8 ohm can measure currents up to 1 ampere. What must be the shunt resistance to enable the ammeter to measure current resistance of the ammeter? So here, 0.24 20. Correct. What are the combined resistance of the ammeter and the shunt? I'll tell you what is the meaning of this. The second problem based on conversion of galvanometer to ammeter is an ammeter of resistance 0.8 ohm can measure current up to 1 ampere. So what we'll start thinking of it is like, we'll first draw an ammeter and then start solving the problem. But remember, this ammeter is what is the new galvanometer. Why? Just because what must be the shunt resistance to enable the ammeter to measure a current up to 5 ampere? Means original galvanometer that you had has already been converted to an ammeter, which can measure up to 1 ampere current. Now you want to upgrade it. So when you want to upgrade it, across this device, you are connecting the resistance. So this first device, which is modified, should have a galvanometer in the second place. So this one, what they have given is, though they use the word ammeter, you should treat it like a galvanometer. Or else not be able to proceed. Are you able to understand why you're doing it? Actually, if you observe, no, the original galvanometer is there, no. The original galvanometer was already connected to a shunt resistance, let's say RSH1. Now, this whole device is acting which can measure ampere. Now, what you want to do? You want to upgrade it. The ampere should increase to 5 amperes. So, for that, what are you supposed to do? Across this circuit, you're connecting another shunt resistance, so that this whole device is able to measure up to. Then, how should you treat this part as? It should be treated like a galvanometer. And this galvanometer is what I've drawn here. Clear this? And across this, how much is the shunt resistance you need to connect? So what is going to be the value of I? This system is going to measure. I will be 5 ampere. What is the value of IG? IG is what is 1 ampere. Here, so how much will this be? 1. How much will it be? 4. So 1 into 0.8 is equal to 4 into R shunt. Sorry, apply the R shunt is equal to IG into RG divided by I minus IG. If you do it, you will get the same answer. Either 10C. So all that I did is, I know that since the numbers are given, out of the 5 ampere, which this ammeter is supposed to measure, 1 is going to the galvanometer and the remaining 4 is going to the shunt. So 1 into RG, that is 0.8, is equal to 4 into R shunt. So 4 will cancel this 0.8, 0.10 to this answer. So this is what you got. So R shunt is 0.2 ohm. You need to connect this amount of resistance in parallel to the original ammeter. So what is the combined resistance of the ammeter and shunt? So this itself has a resistance of 0.8 and this has a resistance of 0.2. Okay. So 0.8 and 0.2, what is going to be the resistance of the new ammeter, which I'll call it as RA dash, which will be 0.8 into 0.2 divided by 0.8 plus 0.2 is 1. So answer will be 16. So 0.16. 2 decimals to the left, no? So 0.16 ohm. That's the answer. Right? So these kind of problems will be asked based on conversion. Right? There are a few more problems which are given in your textbook. Last problems of additional exercise which are based on conversion. So you can try out those problems on your own. If you have any doubt, you can reach out. Okay. So with this, we are done with fourth chapter, right? And I missed to teach one concept that is not solenoid. Solenoid, I'll give it, but I forgot to explain about velocity selector. Okay. So velocity selector alone, I'm not going to test in this exam. I'll not ask. So apart from that, everything will be asked. So prepare accordingly. Selector. Chinna concept, but I missed to explain it. I'll do it later. So except that velocity selector is new book. Older. New book it's in page 140 in the new book. In page 140, topic 4.4.1 is new book. Cyclotron 140 page. Cyclotron is not there, no? NCERT irka. Na website la check panna illa cyclotron. See, velocity selector is not given as a separate concept, but that is needed for electromagnetic waves also. But it's fine. That I'll explain as a very but not today. So that will not be tested. Apart from that, you have to prepare for everything. Okay. So fifth chapter. That will go fast. Okay. So any other questions? All clear? Okay. Then we'll wind up this. Laya, are you there?
Yes, sir.
Yeah, we'll wind up. You have any questions?
No, sir.
Okay.
Sir,
Yeah.
will we be tested like solenoid? Is those topic included for the exam?
Which one?
Solenoid topics.
Yeah, solenoid will be there. But mostly I might not frame that question. You can read it.
Okay,
Okay, but I want you to read and be ready.
okay, sir.
Yeah.
Thank you, sir.